everyone, it's Miss Joyce. Today we'll be reviewing for the Module 2 assessment. Let's start with dividing 5,454 divided by 4. First we'll set up our standard algorithm. On the inside we'll place our dividend, 5,454, and on the outside we'll place the divisor 4. Let's list out our multiples of our divisor 4 to help us divide. We have 4, 8, 12, 16, 20, 24, 28, 32, and 36. Let's first start by sharing the biggest place value, which in this number is the thousands place. We have 5 thousands. So we're going to look at our multiples of 4 to see which gets us closest to 5 without going over. Well, we can see the first multiple of 4 gets us closest to 5 without going over. So since this is our first multiple, we're going to place a 1 up here in the quotient in the thousands place. We're going to go ahead and subtract 4 thousands. So we can also get this 4 by multiplying 1 times 4 to get 4. When we subtract 5 thousands that we have all together minus the 4 thousands we're sharing, we get 1,000 left over. We can rewrite this as hundreds by bringing down the next digit, the 4, in the hundreds place. We have 14 hundreds. So if we look at our multiples of 4, we can see which multiple gets us closest to 14 without going over, and that would be the third multiple of 4, which gets us to 12. That means each group is going to get 3 hundreds. So in the hundreds place, we're going to place a 3 up here in our quotient. 3 hundreds per group times 4 groups gets us 1,200 shared all together. So we can now subtract the 14 hundreds that we have in total minus the 1,200s we're sharing to get 200s left over. We can rewrite this as tens by bringing down the next digit, the 5, which is in the tens place. So we have 25 tens. Let's look at our multiples of 4 to see which gets us closest to 25 without going over. That would be the 6th multiple, 24. So that means each group is going to get 6 tens. So we'll place the 6 in the tens place. 6 tens per group times 4 groups means we're sharing 24 tens. So we can go ahead and subtract the 25 tens we have minus the 24 tens that we're going to share to get 1 10 left over. We can rewrite this as ones by bringing down the next digit, which is the 4 in the ones place. We have 14 ones. We can look at our multiples of 4 to see which gets us closest to 14 without going over. That would be the third multiple of 4, which gets us to 12. So that means each group is going to get 3 ones. So we'll place the 3 in the ones place. 3 ones in each group times 4 groups means we're sharing 12 ones. So we're going to go ahead and subtract 12. 14 ones that we have in total minus the 12 ones we're sharing in all leaves us with 2 ones left over. Since there are no other digits to bring down, the 2 is going to be our remainder. So our quotient, or answer, is 1,363, remainder 2. Now let's try 2,545 divided by 11. First we'll create our division symbol and place the dividend, 2,545, on the inside and the divisor 11 on the outside. Let's list our multiples of our divisor 11 to help us divide. We have 11, 22, 33, 44, 55, 66, 77, 88, and 99. Let's first start by sharing our biggest place value, which in this number is the thousands place. We have 2 thousands. So we're going to go ahead and see our multiples of 11 to see which gets us closest to 2 thousands without going over. Well, we can see that this first multiple already gets us to 11. Well, we don't have 11 thousands to share, so we can't even give each group 1,000. So we're going to place a 0 up here in the thousands place, showing we're going to give each group 0 thousands. If we give each group 0 thousands, that means we're sharing a total of 0 thousands. So when we subtract the 2 thousands we had minus the 0 thousands we're sharing, we still have 2 thousands left over. We can rewrite this as hundreds by bringing down the next digit, which is the 5 in the hundreds place. So we have 25 hundreds. Let's look at our multiples of 11 to see which gets us closest to 25 without going over. Well, we can see the second multiple gets us to 22. So we're going to give each group 2 hundreds. So in the hundreds place, we're going to put a 2. So if we give each group 2 hundreds, and there are 11 groups, we're going to share a total of 22 hundreds. When we subtract the 25 hundreds we have, minus the 22 hundreds we're sharing, we have 3 hundreds left over. We can rewrite this 3 hundreds in tens by bringing down the next digit, which is the 4 in the tens place. We have 34 tens. Let's look at our multiples of 11 to see which gets us closest to 34 without going over. That would be the third multiple of 11, which gets us to 33. So we're going to give each group 3 tens. So if we give each group 3 tens, and there are 11 groups, we're sharing a total of 33 tens. When we subtract the 34 tens we had, minus the 3 tens we're sharing, we have 1 10 left over. We can rewrite this as ones by bringing down the next digit, which is the 5 in the ones place. We have 15 ones. We can look at our multiples of 11 to see which gets us closest to 15 without going over. That would be our first multiple of 11. So we're going to give each group 1 1. If we give each group 1 1, and there are 11 groups, we're sharing a total of 11 ones. So when we subtract the 15 ones we had, minus the 11 ones we've shared, we have 4 ones left over. There are no other digits to bring down, so the 4 is our remainder. Our quotient, or answer, is 231, remainder 4. Let's try some decimal division. Jenna says that 15 divided by 6 equals 11 divided by 4 because both are 2 remainder 3. Show her a mistake by using decimal division. So let's go ahead and start by dividing 15 divided by 6. So we'll create our standard algorithm. 15 goes on the inside, 6 goes on the outside. First, we're going to look at the tens because that's our biggest place value in this number. Well, the first multiple of 6 would already get us 6. That's too big. So we have to place a 0 up here in the tens place. 0 times 6 gets us 0. When we subtract 1 minus 0, we get 1 left over. So we have 110. We can rewrite this as ones by bringing down the next digit, which is the 5 in the ones place, to get us 15 ones. Let's think of our multiples of 6 that will get us closest to 15 without going over. Well, 6 times 2 gets us to 12, which is as close as we can get to 15 without going over. So we're going to give each group 2 ones into 6 groups, which is why we're sharing a total of 12 ones. When we subtract 15 minus 12, we get 3 ones left over. There are no other digits to bring down, so what we can do is we can rewrite this as a decimal. Instead of saying remainder 3, we can say that there are 0 tenths since there are no tenths there. Remember, the decimal point goes between the ones and the tenths place. So there are 0 tenths, so we're going to bring down the digit 0 to rewrite this as 30 tenths. Now let's think, what can we multiply by 6 to get closest to 30 without going over? Well, that would be 5, since 5 tenths per group times 6 groups gets us exactly 30 tenths shared. When we subtract 30 tenths minus the 30 tenths we're sharing, we get 0 tenths left over. Since we have a 0 here, we are done dividing because we now have 0 left over. So the answer here would be 2 and 5 tenths. Let's go ahead and divide 11 divided by 4 to see what this answer would be as a decimal. So in the inside, we're going to put 11, and on the outside, we're going to put 4. Let's start by sharing the biggest place value, which would be the 1 in the tens place. So we're trying to get as close as we can to 1 without going over. Well, the first multiple of 4 would already be 4. That's too big. So we're going to place a 0 up here in the tens place, showing we're giving each group 0 tens. 0 times 4 is 0, so we're sharing a total of 0 tens. When we subtract, we still have 1 10 left over. We can rewrite this as ones by bringing down the next digit, which is the 1 in the ones place. So we have 11 ones. Well, let's think, what can we multiply by 4 to get closest to 11 without going over? Well, that would be 2, because 2 times 4 is 8. So we're going to give each group 2 ones to each of the 4 groups, which means we're sharing a total of 8 ones. When we subtract 11 minus 8, we get 3 left over. So we could rewrite this as 3 as a remainder, or we could rewrite this as a decimal. So notice there are no other digits to bring down. Since we're going to rewrite this as a decimal, we can write that there are 0 tenths here. Remember, the decimal point always goes between the ones and the tenths place. So we can rewrite these 3 ones as 30 tenths by bringing down the 0 in the tenths place. Now let's ask ourselves, what can we multiply by 4 to get closest to 30 without going over? Well, 4 times 7 is going to get us closest to 30, since 7 times 4 gets us to 28. So that means we're going to give each group 7 tenths. For each of the 4 groups, we're sharing a total of 28 tenths. When we subtract 30 minus 28, we get 2 left over. Well, we can rewrite these 2 tenths as hundredths by placing a 0 in the hundredths place since there's nothing there. There are no hundredths, which is why we can put a 0. So we'll bring down that 0 to rewrite 2 tenths as 20 hundredths. So let's ask ourselves, what can we multiply by 4 to get closest to 20 without going over? Well, 4 times 5 gets us exactly 20. So we're going to give each group 5 hundredths to each of the 4 groups. So we're going to share a total of 20 hundredths. When we subtract 20 hundredths minus the 20 hundredths we're sharing, we get 0 hundredths left over. So we're at 0 now. We are done dividing. Notice this answer is 2 and 75 hundredths. So even though both of these answers are 2 remainder 3, if we represent our remainders as a decimal, we are going to get different answers. Both answers are 2 remainder 3, but 15 divided by 6 is 2 and 5 tenths, while 11 divided by 4 is 2 and 75 hundredths. Now let's interpret the remainder. 32 campers are going skiing. They are taking cars to get there. If each car holds 5 campers, how many campers will be in the car that is not completely filled? Let's start by writing the equation. We have a total of 32 campers, and we are going to put 5 campers in each car. So we can divide 32 divided by 5. Well, this will get us a quotient of 6, remainder 2. We can show that here by creating a visual. So we'll have a car, and we're going to place 1, 2, 3, 4, 5 campers in each car. But we have more than 5 campers. We have 32 campers. So let's create another car. Now we have 6, 7, 8, 9, 10. Oh, we need another car. 11, 12, 13, 14, 15. Ooh, we need another car. 16, 17, 18, 19, 20. We need another car. 21, 22, 23, 24, 25. And another car. 26, 27, 28, 29, 30. Oh, we're so close. We need another car to fit the 31st and 32nd camper. So we can see here there are 1, 2, 3, 4, 5, 6 cars that are completely filled, and then a 7th car which is partially filled. Well, let's look at the question. It says how many campers will be in the car that is not completely filled? So if we look, we can see this car is the only car not completely filled. And we can see there are 2 campers. So if we look at our equation, 2 is our remainder. So we're going to use just the remainder. How many campers will be in that car that is not completely filled? There are 2 campers, 1, 2, in the car that is not completely filled. Let's have the same scenario, but a different question. So the question here says, how many cars are needed so that all campers can go skiing? Let's start by having the equation. It's going to be the same equation, 32 divided by 5, which is going to get us our same quotient, 6 remainder 2. But we want to make sure we're answering the question that's being asked. How many cars are needed so that all campers can go skiing? Well, if we look here, there are 1, 2, 3, 4, 5, 6 cars completely filled, but that means 2 people would have to find another way to go skiing. We need a seventh car in order for all the campers to go skiing. So since we need a seventh car, let's look at our quotient. We need to add one more car to the 6 cars we have so that these 2 campers can still go skiing. So we're going to add 1 to the quotient, meaning we're going to need 7 cars so everyone can go skiing. Let's answer this last question. Same scenario, but now it says how many cars are completely full? So the equation is going to be the same, 32 divided by 5, which is going to get our same quotient, 6 remainder 2. We can see that here because there are 6 cars, 1, 2, 3, 4, 5, 6, that are completely full, and 2 campers in this car that's not completely full. The question says, how many cars are completely full? Well, we can see on the right, there are 6 cars completely full. So if we look at our quotient, 6 is our quotient. So what we're going to do is drop the remainder. To answer the question of how many cars are completely full, there are 6 cars completely full.